Hi everyone, welcome to another Dapr community call, number 102. I'm Mark Duiker, one of the Dapr community managers. And as you can see, I'm not in my regular spot, I'm not in my office at home. I'm in a hotel room in London. I was meeting up with some colleagues today and also yesterday, which was really great. But unfortunately, I don't have all my regular equipment here available. So I hope the hotel Wi-Fi is good. I hope the audio is not too bad. But yeah, well, we'll see how it goes today. So let's have a look at the agenda. So first we have a session about Dapr and WASM by Sven Pennick. I heard Christoph, the other speaker, is not here. Then I'll show you the new Dapr slide deck, which has been out there for a couple of weeks now, and I did see it used in some places, but we never really introduced it, so it's a good moment to do that. And we will conclude with the regular show and tell section about all of the blog posts, videos, and social messages that we have found about Dapr in the last 2 weeks. So let's have Sven join us so he can start with a session about Dapr and WASM. Welcome, Sven.
Hi, hello. Great to be here.
Yeah, thanks so much for joining and sharing some knowledge. And yeah, I already mentioned before when you just joined, I'm a bit jealous of your beautiful mustache. It's really
Thank you.
nice. All right, I will stop sharing my screen and you can start sharing. And then,
Okay, so take over
of
the screen
course,
share. So hopefully you
yes.
see some slides. Yeah, great to be here. So I want to talk a little bit about Dapr and WebAssembly. So if you have any questions or want to know anything, I would keep it more casual. So just directly write a comment and ask a question. I try to, react on that. So yeah, that's me. So I'm Sven Fennick, Principal Consultant for Software Engineering at Liquid Reply. I'm working on development of cloud-native applications for hybrid and multi-cloud clusters. I'm also tech lead of the WebAssembly working group, and yesterday I was informed that I'm a CNCF ambassador for the latest batch of ambassadors. Christoph, unfortunately, can't be here today. So greetings if you see the recording. So I hope you enjoy it. We have a question in the chat, but I think that's better for some Dapr people to answer if there is a good Python tutorial. Let's dive into what is WebAssembly. So I assume most of the people know what Dapr is if you tune into this channel, and therefore I start with WebAssembly. In a nutshell, WebAssembly is a compilation target and a low-level binary instruction format. So you get bytecode that's interpreted, and your runtime handles a lot of things for you. And the interesting things are that it's portable, so you don't need to care about your processor architecture or your platform you're running on. If it's Unix, if it's Windows, if it's an Intel CPU or an ARM CPU. So if your runtime is able to run on that system, you can run your WebAssembly. And there are a lot of runtimes out there. It's sandbox by nature. So you have very strong security constraints, which makes it very interesting for a lot of use cases, especially for IoT or data that is restricted. So you can build very safe applications with the sandbox. And it's fast. So you have near native performance, which is especially interesting if you are coming from an, I would say, more interpreted language that is slower from the interpreter than WebAssembly is usually faster, which is the, I would say, default use case in the browser. So when you are used to run JavaScript in your browser and can switch the CPU intensive workload to WebAssembly, you get a performance boost. And that is, I would say, one of the origins of WebAssembly. And one of my favorite points, it's language independent. So you can, if you can compile your language to this bytecode format, you can run it in a WebAssembly runtime, which means almost all compiled languages are able to work this way. Some interpreted languages are working as well. So there are runtimes for Ruby, for Python, for JavaScript, which is a little bit funny, but it's working pretty well. And so if your language ecosystem is flexible enough to compile to this bytecode, then you can run your language in WebAssembly. How does it look like? So when you have a function, it's compiled to a .wasm file, which is the binary representation of WebAssembly. There's also a text representation. You can every binary every bytecode file can be translated to a more readable WebAssembly text file. It looks a little bit like assembly language. That's where the name originates from, but in fact, it's higher level instructions. And then you load your WebAssembly module into runtime. And there are different modes to do that. So either you have a standalone runtime that executes your WebAssembly, or you can have an SDK in your host application and run it as a plugin. So WebAssembly as plugin system is very popular. And yeah, so the security constraints and the isolation from your host application makes it a very great application to write plugins in WebAssembly that can't crash your host application. How can WebAssembly and Dapr get together? So they have goals in common. So both technologies try to avoid boilerplate code and make code more reusable. They try to have a low overhead, separation of concerns. Both are looking at security in different angles. And you have the freedom of choice. So you are not bound to a specific programming language or tooling. You can still choose. But the way they are implementing it are completely different. So in Dapr, you have a standalone service besides next to your application, and you communicate with a universal interface like HTTP or gRPC. In WebAssembly, you compile your application to a bytecode format and have well-defined APIs inside the runtime. They are called WASI, the WebAssembly Systems Interface, and with those APIs, you can access, for example, host resources or other APIs. So it's different in the way they are doing it, and this is giving us some things we can pick from. So WebAssembly is interesting because we have this runtime security, we have a tiny footprint, we can choose our language, and we have the platform independence. So everywhere where Dapr can run, WebAssembly can run as well. And Dapr is, I would say, the tooling we have, the integrations that are already available, are not in every language and every runtime possible in WebAssembly. But WebAssembly can have in almost every runtime open and can open an HTTP server and do HTTP requests, which makes the symbiosis of both technology very interesting, because I can leverage all of the bindings, all of the already existing integrations Dapr has in my WebAssembly application while the ecosystem is maturing. So as I said, there are a lot of runtimes. I don't want to list them all. And a lot of languages we can use. So I have here I would say, list of things where we can get start, but I don't want to show all of them, because it would be, I would say, more confusing than it's helpful. What I want to show is two things. The first thing is Dapr already comes with an integrated WebAssembly runtime. It's called WASM. It's completely written in Go. And the name comes from the fact that WASM has zero external dependencies. So it's all written in Go. And when you can compile it with your Go compiler, so if there's a target, then it's running there, which is, I would say, very interesting. You don't need CGO. And that makes it, for Go applications, an incredible way to run plugins or extension code from a user. In Dapr, when you know the documentation, there are two ways of running WebAssembly in Dapr. First thing is the Dapr middleware. So you can have an HTTP middleware written in WebAssembly. And the second thing is an binding, so an output binding for WebAssembly. And that's something I would like to show. So when we look at our binding, then we have a component from type bindings WASM. And here we load a WebAssembly file. And this is something I would say a little bit special. This example is from the official documentation of Dapr, and we are loading from VMware Labs. They have pre-compiled runtimes, and here we are loading the Ruby runtime, which means we have an output binding where we can send a payload to, that's then interpreted by a Ruby runtime. How does it look like? So I have Dapr running locally, and with the WebAssembly binding, I can say execute. The arguments are my Ruby program. I can add some data, and if I run that, I get the answer from my Ruby runtime that is compiled to WebAssembly and running in Dapr. And I can then, from my application, for example, if I have some Ruby or some Python snippets, can let the interpreter does the work, get the result back, and do my usual tasks. So that, I would say, something very interesting, and you don't need any external dependencies. You just need an I would say, standard Dapr, and can get started with WebAssembly out of the box, which in my opinion is pretty amazing. So the next thing, or the other thing I would say, show is on the completely other side. So it's not the most simple way to run WebAssembly with Dapr. I would say it's a more complex way, and does need an Kubernetes installation. So first, I want to just mention that there are two other ways. So with standalone runtimes, for example, like WASM Edge. WASM Edge is namely mentioned because they have a Dapr SDK for WASM Edge. and it's working like most of the other Dapr SDKs, but when in this case, when you're using Rust in a WebAssembly runtime, you don't have all of the capabilities you have on an, for example, Unix system. So you can't open sockets usually. There are some ways in WASM Edge that make it possible, but therefore they need an adapted SDK. Long story short, there is an SDK for Dapr in WASM Edge, and it's an interesting project, just want to mention it. On the other side, there is the Spin framework, which is built on WASM time. And so that's I would say more simple way to execute Dapr. So you're doing requests and opening routes and do the HTTP communication manually. However, on this KubeCon, the Spin Cube project was announced, which is all of the things that is needed to make the Spin framework applications run on Kubernetes with so-called WebAssembly containers. Is put together in one project, and it's submitted to the CNCF as proposal for a sandbox project. Exactly. And I just want to go through the steps to set up a Kubernetes cluster that can run WebAssembly containers, which are way smaller than classical Linux containers, and have the advantage that you don't need an init system or any bash or anything. So you don't only have your WebAssembly application in that container, which makes them small and way more secure. You have a smaller attack surface. And of course, since it's still in Kubernetes pod, you can annotate it and run it with Dapr like you would do your classical applications you are creating today. Okay. The first things we would need to do is creating a Kubernetes cluster. In this case, I have already set up an K3D with the official sorry, too many things at the same time. With the official SpinCube quick start. That means we have already the runtime classes enabled we need. And Dapr is already installed with Dapr -K. So we have SpinCube and Dapr already running. Then there's another link on the slide deck, which is a dev.to article from Tangchung. And there it's very good. There's a very good description what needs to be done to make this setup with SpinCube and Dapr working. In the end, we can go to Dapr Labs and Polyglot, the product API. With Spin comes with an CLI tool. It's also called Spin. And it can directly build the application, pack it into an OCI registry, and make it create an application that can be handled by Containerd. That's it. I used here ttl.sh, which is an ephemeral registry where you can just push images and they are deleted after some time. As soon as I have done that, I can already deploy this image I have created here. So this is a spin app, which is handled by the operator. So the spin app operator. I choose the image, my executor, which is only possible in this K3D version from the QuickStart, the replicas, and enable Dapr with annotations. When we look at the pods that are here, my bad, I have already run this application. So I, of course, also started a Redis server. Otherwise, my application would not work. But in the default namespace, I have my Redis server and the just created product API with my product app and Dapr running, like you would expect it if you created without WebAssembly. So there's nothing special here. Then we have an ingress to make this API available. Here is, that's nothing I would say interesting. I've just created an ingress to make the K3D servers accessible on my local machine. And then my application is already working, which, I would say is a very simple way to make such a complex stack working. I can just recommend looking at the quick start, looking at the great DevTO article, and then I would, stop with the things that are possible today, and give a little outlook on what could be the future of the integration with WebAssembly and Dapr. There is a WASI proposal, which is you can watch the talk from Joe and Bailey from WASM Day, which was co-located at the KubeCon in Paris. And so there is a proposal for a WASI Cloud Core, which has the integrations for key value store, for messaging, for HTTP, runtime config, SQL, and blob store, which in my opinion would be a perfect fit if that could be implemented by Dapr. So the idea behind components is that you can just swap the implementation out and run locally, for example, another implementation than on your cloud provider. And so that would be my preferred way to integrate Dapr, or to use Dapr in the future with WebAssembly. And let's see if that's possible. Now my slides are gone. No problem. It is a problem. So I'm at the end of the presentation. So last slide would only be the outlook.
I can quickly maybe
Thank you, Mark.
share them.
Thank you, Mark.
This one?
Yeah, exactly. So just want to encourage everybody who is interested. There are a lot of resources out there. For example, there are many live projects for Rust and WebAssembly with WASM Edge. There is the WASM Dapr project. So a template where you can just start with Dapr and WebAssembly. And we have a course on Dapr and WebAssembly, which is stay tuned. It's live, so just a few days. So quick, hot out of the press. And if you are just looking for Linux Foundation courses and Dapr and WebAssembly, it's an official Linux Foundation course. You can look at exactly this combination with WASM Edge and Dapr. If you are interested more in WebAssembly on Kubernetes, there is also a great course from Sayam Pathak. Just on YouTube, if you need to learn everything about WebAssembly from starting point till now in about 3 hours, then it's a very great thing. And SpinTube, the project I've used in this demo, is about to be a sandbox project in the CNCF. So crossing fingers that the application is working well. That's it. Thank you.
Very cool, Sven. Thanks a lot. So what, in your opinion, what's now the easiest way for developers completely new to WASM to start? I mean, obviously it's probably that Linux Foundation course about Dapr with WebAssembly. But what type of WASM runtime is the most ideal or easy to start with?
That is an awesome question. So usually when you're new to WebAssembly, you are overwhelmed with all the runtimes and where you can run WebAssembly. So you can run WebAssembly in a browser. Every Node.js like runtime like Bun, Deno, or whatever you name it can run WebAssembly. There are standalone runtimes, and every runtime is specialized in a specific field. Most of them are, I would say, or how do I say it, ahead of standard. So they bring you some extra features that are not in the standard, because the standard is, I would say, pretty stable, but slow moving. And there sometimes features are added that are not in the standard yet and may change in the future. So to be short, if you are using Rust and WASM Edge, the simplest way I would say is the SDK, and then you can just get started. If you have another runtime and language combination, you usually need to fall back to the HTTP API, which is in case of Dapr pretty well defined. It isn't that bad. So from a Dapr perspective, WebAssembly is just another client language tool like Node.js, like Go, like JavaScript, whatever you are using. So therefore, it's not that different in using Dapr. But when you're new to WebAssembly, I would recommend either using something like Spin, which gives you a lot of foundation and things around your, so you get a little ecosystem in the ecosystem where you have all the tools you need at hand, or something like WASM Edge, where you can say, okay, I compile everything in my application to WebAssembly and let it run. It feels more like, I would say, a native development.
Okay. Yeah. Right.
Whatever you prefer.
Yeah. Well, yeah. So sometimes having too many options is quite difficult then to get started with, right? So this was like okay.
Yeah, and I'm always feel sorry in this situation, because there are so many great other runtimes out there which are all worth to have a look at. So, but it mostly confuses when I go through all of the options that are available.
Yeah, exactly. All right. All right. No, but thank you. This was like a good introduction with also lots of links, and we will also, oh yeah, the slides will be available in the description anyway. But we'll also mention the Linux Foundation course as well. We'll also put the link out there in the description as well.
Amazing.
Cool. Right. Thank you very much, Sven.
Yeah, was a pleasure. So thank you for having me.
All right. Let's move on to the next section. All right. And that is the new Dapr slide deck. So if you go to the docs, this URL, docs.dapr.io/contributing/presentations, there is a link there to new PowerPoint template file of Dapr slide deck. And actually share my screen now as well. I'll do the entire screen. We'll get a bit of window effect, but that will be gone soon. All right. So this is the entire Dapr slide deck, which is a very big file. It contains like over 140 slides, but it's really used to be like a starting point for your own custom Dapr presentations. So it contains a lot of stuff that you can probably use as is, but it contains like too much for just one presentation about Dapr. I think you need like over 2 hours to talk about every slide. So really use this the same as Dapr. You use the different building blocks of Dapr to create your applications, but also use the different slides and diagrams in this PowerPoint template to create your own slide deck for Dapr. Now, the first couple of slides are hidden, and they explain how you would actually use this slide deck, right? So it also acts as a bit of a branding guide for using for Dapr. And at the end of the deck, there's also a lot of slides with a lot of assets, lots of images and logos and icons and so on. So then the first 2-3 slides just explain a bit what everything means, what kind of logos and templates you can use, what kind of shapes you can use, preferred colors and stuff like that. And then the reason that we upgraded this is because, well, like a couple of months ago, the Dapr website was sort of rebranded and restyled in a much fresher way. But all of the other assets are still in the old style. So now also this Dapr slide deck is refreshed, and of course it will take some time before also all of the images in the docs will be replaced, but that will happen as well. So I will not go through everything in the slide deck. I will just point out a couple of things. Let me see if everything is still okay here. Yeah, all right. So we start out with just giving some kind of a context, right? So a lot of organizations are building distributed applications, and then you need to worry about or think about how can you do like orchestrate business logic across these services. You need to think about how you can do like distributed tracing across services, and also across and message brokers. You need to think about how you can configure access to services and other resources, and how you deal with resiliency and retries. And the answer is they want to offer is the Dapr distributed application runtime, because Dapr takes care of all the heavy lifting and it sits in a sidecar next to your application. Some of the other new things are, for instance, the Dapr from development to hosting part, because we have like a different icons and images now for all of the different APIs. Now also includes middleware. Also the cross-cutting concerns also have some different icons now. And we can also see that in the Dapr components overview, where we see all of the APIs and the different components that they support. This is just a subsection of the components, because there are like over 120 components now. This is like the more familiar ones are here. Some new things is, for instance, this slide. This is actually like an animated slide. So this is just an example of a couple of applications that show how to use these 6 different Dapr APIs, so external configuration, secrets, PubSub, certification, state management, and bindings. So let's say you have an application that gets triggered by a Dapr input binding. That application then uses the secrets API to get a secret that uses the service verification endpoint to call out to application B. That application B calls out to retrieve a configuration value using the Dapr API. Then application A does use the publish API to post a message to a message broker. Application C is subscribed to this endpoint. And then application C uses the state API to save some state and also uses a output binding as well. So this is just to quickly show to the developer audience what kind of integrations there are within Dapr that you can do in your applications. There's also a bit in there about the community that was also already there, but this is refreshed. We also have, I think, also a couple of new logos in the Dapr users as well. And then for each of the APIs, we have like a main slide and what it is, and then usually some kind of a diagram with the applications and the sidecar and how the communication flows, and also a code sample. I think we have like different languages for all the different parts. So this was the service verification one, and this then describes the sub API. Again, just with a description and also a diagram that explains the flow. And again, some code samples. I'm not going to cover all the APIs, but we have, of course, like a state management example. We have like quite a big section on Dapr workflow, because our workflow is quite a big thing. There's all kinds of different patterns that it enables. So this one is also an animated slide. But then we cover all of the different, let's say, workflow models or workflow patterns that the Dapr workflow enables. So those are also there, also with some code samples. So we cover all of the different patterns there, and we also go a bit into depth about how does it work with the built-in workflow engine. Then we talk about the bindings API, both input and output bindings. Secrets management API is in there. External configuration API, actors, also with some code samples again. Distributed log API is there, also with some diagrams. And the final one, the cryptography API. Then we cover the 3 cross-content concerns. So there's a couple of slides about security, how the MTLS works, but also how you deal with access policies. Then there's a slide about observability, and we have a couple of slides about resiliency between applications, but also between applications and message brokers. Then there's a section about different hosting modes. So we always had like self-hosted on VMs or virtual machines and Kubernetes, but we also introduced now the serverless hosting mode, because we have now Azure Container Apps, which is considered serverless, and also Diagram Catalyst. So those are all described, each with their different diagrams. And then we end with, of course, more Dapr resources, but also we include the link to actually claim one of the Dapr community supported badges. So we would appreciate if you all always can show this slide at the end of your presentation, so people can actually claim this badge and be also a Dapr supporter. Then the final section of the slide deck are lots of hidden slides again, but they contain a bit more information about, again, which fonts do we use. So it's Space Groteska in this case. We mentioned the different colors. We have images for all of the different icons and for all of the APIs and components. Also, we have the individual icons as well. And then we have lots of reusable diagram elements that you can use to create your own diagrams and slides. And because, of course, you might want to draw your own application architecture, so you can just mix and match all of these different assets, these databases and message brokers and other shapes to create your own diagrams. Also, the Dapr sidecar things are also there. We also have some other logos for languages and runtimes. We also have like a set of other icons that you're probably likely to use at one point. So yeah, there's a lot of information in there. Yeah, and please use this, share this. Also, this slide deck is checked into GitHub, so it's also open source. So if you see an opportunity to improve the slide deck, you are free to open a pull request and make some changes there as well. Let me stop. All right. Let me add this back in now. Oh yeah, let me share actually the web page. Present. Okay, I'll do the entire screen again. If I can escape it now. No, I can't. Let me see how I can do this easily. Yeah, I need to just share individual windows. All right, so this is the page inside Dapr Docs about contributing in the form of presentations. Because also sharing Dapr knowledge is also a form of contributing to Dapr. So this is the place where you can download the Dapr slide deck. As I mentioned, it's only a PowerPoint template. If you use it on a Mac OS and you don't have the font installed, the content will be unreadable. So if you're on a Mac OS and you do want to use this file, please make sure you install the Space Grotesque font via this brew install command, because otherwise it's unreadable, unfortunately. Okay, let's get back. Okay, then just a couple of other things. Let's add this back because it's now time for the regular community show and tell section. So we have like a couple of blog posts here. So again, I need to share this one by one. It's not the quickest. Next time I'll have like multiple monitors again, which is a bit easier. So this is a blog post by Anthony Simon, who wrote about .NET Aspire and Dapr. So he claims it's the best way to experiment with Dapr during local development. So if you're doing in Dapr with .NET, then definitely have a look at this article. All right, and the next one, there's a lot of back and forth. The next one is about Dapr and Azure Secrets. Let me share this again. So this is this article on Medium by Quinten Eng. So they describe what you will, in this case, about Azure Key Vault as the secret component. So it's quite like a detailed step how to set everything up. So if you're interested in using Dapr with the secret component and using Azure Key Vault, have a look at this article. Right. And the final one is an article that I wrote. Present again. That is this one. That's an article I published on Dev2. So Diagrid is hosting a hackathon for Catalyst. So it's now in a private preview. But we want, of course, a lot of people to try it and give us feedback how to improve Catalyst. And you can see Catalyst as like a way to actually to use Dapr in a serverless way. Right? So Catalyst provides you all of the Dapr APIs, so you can use Dapr on any kind of compute. You don't have to run on top of Kubernetes anymore. So if you're interested in joining the hackathon, there are actually some money prizes involved as well. So you have to use Catalyst and you have to use AWS. So those are the major two things that you have to use. There are, of course, a couple of other rules there in place, but yeah, feel free to join this hackathon. It starts this month for a couple of weeks, and Kendall, one of the product managers, will create lots of webinar content to help you actually get started with this hackathon. All right. All right, then what we found on YouTube. So another colleague of mine, Cassie, she's a Dapr contributor, and she also responsible for actually standardizing the Dapr errors. So she gave a talk about that at the Open Source Summit recently. and this actually links to that recording. So definitely have a look there. And by the way, we still want some help there with the error standardization in Dapr, because still a lot of the SDKs and all of the APIs still need to be updated with this standardized way of error handling. So yeah, if you want to help us there, please reach out on the Dapr Discord, because it would be great if we get some help there. Then another one that we found on YouTube is on the Carlos Santana's channel. It's like there's like CNCF Communities Book Club, and it's the topic of the last recording was the platform engineering book on Kubernetes by Mauricio Salentino, another colleague of mine. So they were talking about Dapr and features in this review. Then the final one that we found on YouTube was from William Liebenberg. He works for SSW, and he was explaining, I think this was like a snippet from a larger recording about Dapr and how the Dapr sidecar works. And that actually is much easier for you as a developer, because you can actually forget certain things. You don't need to think about that, because the Dapr sidecar is responsible for these things, right? So if you talk about resiliency, you don't have to build it yourself, or you don't have to install packages for resiliency, because the Dapr sidecar is responsible for that resiliency. Then the stuff we found on socials. So we found a post about Cecil, one of the other Dapr community managers, doing a session at the APPConf. That is pretty soon already. I'm not sure if I see the date here, but I think it was already this month that he's doing this session about Dapr. Then in the bottom left is Marcel de Vries. He works at Xebia in the Netherlands. And he is doing 2 sessions at Visual Studio Live, and one of the sessions is about microservices made easy with Dapr. So thank you, Marcel. Then in the middle we have a message from Laurent, who now has claimed one of the Dapr badges. So there are a couple of Dapr badges that you can claim now, and if you are doing presentations, you can actually make a pull request in the Dapr community repo. I'll share that in a second. And if you make a pull request there and include a link about your presentation or a blog post that you wrote, you get awarded either the Dapr Presenter badge or the Dapr Writer badge. Then on the top right, it's my colleague Mauricio Salentino, who was at DevOps Greece talking about Dapr. And on the bottom right, it's me. I was giving a Dapr session about actors in Utrecht, in the Netherlands. I think the final social posts were what we found on LinkedIn. Again, it's the reference to the session that Cassie gave at the Open Source Summit. Then in the middle is Carlos, who is sharing another Dapr badge of the SDK contributors. So if you contribute to one of the Dapr SDKs, you can be awarded with this badge. And then at the bottom right, it's the Linux Foundation the training that Sven mentioned earlier. So you can actually enroll for this training, Dapr with WebAssembly, and we will include this link in the description. All right. So as I mentioned, there are a couple of new badges now that you can claim by contributing to Dapr. And contributing to Dapr does not only mean that you contribute to source code, but also if you write about Dapr, or if you give a presentation about Dapr, or you give a workshop about Dapr, then you can also claim these badges. So in the Dapr community repo, I'll actually share my screen again. It's been a while. In the community repo, there are like 2 folders. So this is the presentations folder, and there's a README here. So if you ever gave a Dapr presentation, you can make a pull request to this README file. You add a row here with your name, GitHub handle, the events that you presented on, and then this link can be either a YouTube link, or it could maybe link to an event page for the session, or maybe a blog post where you gave a summary about this session. So if you make a pull request, then one of the Dapr community managers will award you with this Dapr Presenter badge. The other one is the blog post one. So that this one. So if you write about Dapr or have written about Dapr, you can make a pull request to this table, enter a record here with your name, GitHub handle, and a link to the blog post. And then you'll get this Dapr Writer badge. All right. Okay, so this badge, it was the first one that got created, and this one is free to claim. You don't have to do anything for it. So everyone who is like sticking around on either LinkedIn or Twitter or YouTube, feel free to grab your phone or go to this URL, bit.ly/Dapr-supporter. You need to log in with your GitHub profile, and then you can claim this badge. I did not actually show you yet what you can do once you have this badge. So let me actually present my screen for one final time. So for instance, what you can do is you can embed because the platform that we use is called Holopin. So these are like Holopin digital badges, and you can put them on like a virtual sticker board. So think of this as your virtual laptop actually, where you can put all these stickers and you can move them around on the Holopin platform itself. But you can then include like a static image of that digital board in any HTML file, but also in a Markdown file. So this is my own GitHub README profile page, and I included a link to my Holopin dashboard there, which contains one of the Dapr badges. So you could do something similar, and you could include it in your GitHub profile or include it in your personal website, for instance. All right. With that, we have covered everything that I wanted to tell. So final slide. Some more Dapr resources for you. So if you're just very new to Dapr, I definitely recommend first going to the Dapr website. There's this Dapr YouTube channel where probably most of you are watching now. We have recordings of all of the over the 100 Dapr community calls, but we also have like sessions for Dapr Day. And by the way, there will be another Dapr Day in October when Dapr is 5 years old, and we will soon open a call for papers for that. So keep your eyes open for that. And if you have questions about Dapr or you want to help the Dapr community, please come to the Dapr Discord. We have like over 7,000 people there, like hundreds of people like active there every day. So it's the best place for Q&A of Dapr. I don't see any questions or things in the comments right now. So with that, I want to thank you again for attending another Dapr community call, and I want to thank Sven again for actually being here and talking and explaining about the Dapr WASM. So thanks everyone, and until the next community call.